So in today's lesson we're going to continue with our vectors work, just to remind ourselves of what we were doing with vectors last week. Let's have a go at these starter questions. Just pause the video, work your way through them, and then I'll reveal the answers just in a few seconds. So we want to double check that we can draw vectors and we can work with them in component form. So pause the video, answers coming up in a second. So here are the answers to the starter questions. First vector, the components told me I should be going 4 along and then 1 down in order to draw vector A. For vector B, components of -3, -2 told me I wanted to come 3 back and 2 down. And the important thing is the arrowheads on both those vectors to show their direction. In the next part, I was asked for the components of -A. Well, basically, I take the components of A, which were 4, -1, and I make them the negative of what they were. So the components of A becomes -4, 1. And in order to quickly draw that, as I've done for you, it comes 4 back to the left and then it goes 1 up. So it looks exactly like vector A, except the arrowhead going the opposite direction. And then in the final part, we just work with the components of A and B. We can multiply them out by the scalars that were in front of them, and then we deal with the x components and the y components to get the final answer. So in today's work we're going to be looking at position vectors. So what's on the board just now and the work example I go through will basically make up the note I would like you to have in your jotter. So probably best just to watch this example as I go through it, then pause the video and you can get it copied up into your notes jotter. So what we've got, position vectors, they basically describe the journey from the origin to a point on your sort of coordinate axis. So I've got a coordinate axis here, I've marked on 2 points. I've got the point P, which is 1, 5, and Q, which is 4, 3. And we're just going to imagine our journey from the origin to both of these points. So my journey from O to P, the directed line segment, or the journey from O to P, I'm going to call that the vector or position vector P. That would be the journey from the origin to P. So I show the direction with an arrowhead. And basically this journey would be to go 1 along the x-axis and 5 up the y-axis. So I know it's going to have the components 1, 5. Likewise, the journey from the origin to Q, the directed line segment OQ, which we will just call position vector Q, that would be the journey from the origin to Q, and in order to do that I would have to go 4 along and 3 up. That's basically what the coordinate tells me. So that vector would have the components 4, 3. So now what we might be interested in then is what is the journey from P to Q. So what would the components of this vector P to Q be? So this journey here, that's a journey P to Q. Now you might think, well, we did work the other day, I could just look at my x components 1 to 4, think about the move there, or think about the y components moving from 5 to 3. So some of you may already have worked out what the components of this vector journey would be. But what we can hopefully see from the diagram, an alternative way to get from P to Q, obviously this red vector here would be the most direct route, but we could also get from P to Q by going from P back to the origin and then out to Q. So if I came back from P to the origin, I'm basically doing this vector here but in reverse. So I'm doing the negative of P. So this vector that I'm looking for, this journey from P to Q, we are saying you could actually do negative P, and then once you're back at the origin we could travel out this vector here, which is Q. So we could add that Q vector or the position vector Q on. Slightly tidier way to write this is then to say, well, the journey from P to Q could be done by doing Q minus P. So I'm just rearranging this, bringing the positive term to the front, putting the negative term to the end. And this relationship here that we've got now, that becomes quite an important relationship in being able to find vector components between 2 points. So I can now make use of this, and I can say, okay, to get the components for the journey P to Q, why don't we do the position vector Q, which is 4, 3, and subtract from it the position vector P, which is 1, 5. And then I can quickly do 4 take away 1, which is 3, 3 take away 5, which is -2. So what these components tell me then is to do the journey from P to Q, I want to go from P along 3 and down 2. And that's basically the components some of you could have got quite quickly by looking at those points. But this method here is a useful one. If you don't know the points and you're maybe just given the position vectors, then you can find the journey between 2 points quickly. So that example there basically covers what's going to be in the textbook, the questions that I'm about to give you. So it would be worth pausing the video at this point, copying up the note, make sure you understand that example. As always, rewind the video if you need to, and then the questions I would like you to have a go at today in the textbook will be coming up just in a second. So hopefully you found the worked example there useful, and you've been able to follow along. You should now be able to do the exercise that's on page 146, exercise 15.3. I'm suggesting here that you do all questions. The exercise has got some nice progression sort of through it, so it would be good if you could do all of those questions. But you should only be spending about an hour on this assignment. So between the video and these questions, once you've filled your hour, then it's okay to stop. There is no pressure to do all of the questions in the textbook. Just do as much as you can in the normal hour you would have during the lesson. If you need any more support or have any questions, please contact me through Teams, through email, and then I can maybe provide some further video examples if they would be useful.